In this video, we continue with the Computer Science 9618 A-Level curriculum, taking a look at topic 19.1 algorithms, specifically linked list. We're going to be talking about what they are. More importantly, we're going to program it, and then we're going to walk through the code to see what it's actually doing. So let's go ahead and get started. So what are linked lists? Linked lists are simply lists that contain primarily two things. It's going to contain data, and it's going to contain a pointer. The data is the actual item, and it can be anything. It can be integers, it can be strings, it can be characters, whatever the linked list is composed of. Now, the pointer that each item contains makes it different than an array. Now, we've talked about sorting arrays, and we've written algorithms to do so, but as the amount of items grow in our array, so does the amount of time it takes to sort them. With a linked list, we just tack the item right onto the end of our array, we update some pointers, and we're good to go. We don't need to resort all the items, which could take a long time. Now, linked lists are slower than arrays, though, and this is because it can be on different ends of the RAM where the next address is pointed to, while arrays are continuous. So there are some benefits and drawbacks, just like anything. So pointers. There are some pointers and terms you need to be aware of, not just for this video, but talking about linked list in general. We have what's known as a head pointer, which is also known as a start pointer. And this points to the first item in the linked list. You have to know what index of the array we are looking for. Then we have a pointer used to point to the next item in the linked list. We have what's called a null pointer. Now, this is to show there's no other items in the list. Now, a null pointer in programming can be represented as a 0 or a -1. It depends on the starting index of your array. If you omit index 0, then you will be using 0 as your null pointer. If you include index 0, you would use -1 as your null pointer, and you'll see why later today. And then free pointer. It points to the next free index, the open spot in the list, to make sure we can add an item. So let's take a look at our scenario, and then we'll get to programming. So given the following data of names, put them into a sorted linked list with the ability to add a node, remove a node, and another option to traverse the linked list. Now, we'll give our array 10 indexes, so we can add an additional name. So here is our list of names. We have Casey, we have Jim, we have Taj, we have Juan, we have Colby, we have Vinny, we have Riley, and we have Steven. So we have a list of 8 names here, and they are not in order. The reason they are not in order is because they want us to make a sorted linked list. Well, if they're already in order, we're not going to know if it's actually being sorted or not. So let's go ahead and create our table so we know what we can program. So we kept everything in order. This is the index. We omitted slot 0, so our null pointer is going to be 0. And we look at our start pointer, which is 1, which means it's pointing to index 1. We take a look at Casey. What name would come after Casey if we're making it sorted? That would be Colby. What index is Colby in? Colby is in index 5. So what does Casey's pointer need to point to? He needs to point to 5. Then that points to Colby. Colby's next. Colby points to the next item, which is Jim. So Colby is going to point to 2. Jim would point to the next item, which is Juan. Juan points to the next item, which is Riley. Riley points to the next item, which is Steven. Steven points to the next item, which is Taj. Taj points to the last name, which is Vinny in index 6. Now, because we don't have index 0, our null pointer is going to be represented by a 0. Now that Vinny's pointer is 0, we know that we have reached the end of the linked list. So let's go ahead and program this. We're going to switch over to Visual Basic. We're going to be making a console application, .NET Framework. Let's switch over and do that now. Now that we're in Visual Studio, we can go ahead and create some of our variables that we can use as a linked list. The first one is going to be my list. This is going to be the items, and our items were named, so that's going to be a string. We also need next pointer, and we're going to need 10 of those because each item contains a pointer. We are also going to need our start pointer, which is known as a head pointer as well. We're just going to call it start pointer. We're also going to need our free space, the next free index that is available. That is going to be an integer as well, and that should do it. What we're going to do in our submain, the first thing we're going to do is populate our linked list based on the table that we just saw. So we're going to skip ahead where all that is done. So we've created our list of names. We have it here in the array my list, and then each of them also have a pointer. I created choice because we're going to create a menu in just a few moments here. So to do the various things that we need to do. But my list 1, that's our start pointer, which is Casey. Casey points to item 5, which was Colby. Colby points to item 2, which is Jim. So when I follow this down, this will act as a linked list. Go ahead and pause here and update your code. Now that your code is updated, we also need to add in our start pointer, and our start pointer we said is 1. We also need to add the next free space, and our next free space is 9. We have 10 indexes for our array. We only went to 8, so our next free space is 9. That is the free pointer. And what we need to do now is we need to create a menu. So I'm going to do this right here inside my submain. Let's go ahead and fast forward so we can have that menu created. Okay, so we have our menu created. We have some red lines. We'll get rid of those in a minute. We haven't actually created the procedures, view array, add node yet, so we'll get rid of those red lines in a moment. But we simply display a menu, enter the number of what you would like to do. We can view the array, which is important because I want to make a point when we're removing or adding a node later. So I want us to be able to view the standard array. We need to be able to add a node. We need to traverse the linked list, we need to be able to remove a node, and then of course we want to exit the program. It's not going to do us any good to add a node and then have the program exit. So we need to be able to see the updates that it's making. We're using choice, which is the variable. Choice 1 allows us to view the array. 2, add the node. 3, traverse. 4, and remove the node. And of course this is going to loop until we get to choice 5. So the first thing we want to do is we want to view the array, and that is very simple. So we're going to skip ahead to show you what that code looks like, just to save time, because this could turn into a very long video. Taking a look at our view array sub, we created a custom procedure here. We're just going to run a simple count control loop, which is a for I, or a for loop using I. For I equals 1 to 10, if my list 1 or 2 or 3, all of them, if any of them are blank, we're going to say it's open for use. If it's not open, we're going to say what it's occupied by. We have a console.read line here, so it will pause and then it will clear the screen. So let's go ahead and run it and make sure we can view the array. We have our program open, we hit view the array, we can see that index 1 is Casey, followed by Jim, Taj, all the way down for Stephen. We see that index 9 is open for use as well as index 10. So it is working, so we'll go ahead and exit. Now, if you were getting errors, don't forget you may need to go up here, add single apostrophes in front of these procedures that we have not created, because if you leave them there, Visual Studio is going to say, hey, we don't know what that is. We can't find them, so it's going to throw an error. So the next thing we need to do is to be able to traverse the array. So we're going to create our sub, and we're going to call it simply traverse. And then we're going to end the sub. And what we're going to do is we're going to type in the code. We're going to fast forward to that, allow you to type it in, and then go over what it's actually doing. This is our code for sub traverse. We need a current pointer as an integer. Now the reason we are making that local is because we're going to need one when we traverse the sub, add a node, or remove a node. We're going to need a current pointer. It's always going to be equal to our start pointer. Now remember, the start pointer we dimensionalized as soon as the program started. The start pointer is 1, which is going to be the current pointer because we need to check the first item. So we simply output the pointer or the item. We're going to say what it points to, then we're going to pause the program, hit enter so we can see what the next one is. So let's go ahead and make sure this matches what we had earlier in our table. Our program is running, we traverse the linked list. I guess we should have made that 2, but it's fine, we'll just leave it as 3. Casey points to 5, that was Colby. Colby points to 2, notice, so far it is sorted. Colby points to 2. That points to Jim. Jim comes after Colby. We're talking about alphabetical order here if you want to know what I mean by sorted. Then Jim points to index 4, which is Juan. Juan points to 7, which points to Riley. Riley points to index 8, which is Stephen. Stephen points to 3, which points to Taj. Taj's pointer is pointing to 6, which points to Vinny. Now, Vinny's pointer is 0, which means we have reached the end of the linked list. All names are there, and all names are in order. We have traversed the linked list appropriately because the items are in order. So let's talk about what the code is actually doing here. So what is the code doing here? Because there's a lot of variables at play. There's a start pointer, current pointer, next pointer. There's my list. There's a bunch of stuff going on here. So what we need to do is we need to look at the code. So here's our code. Dim current pointer is integer. I think we know what that does. That dimensionalizes a variable. Current pointer equals start pointer. Well, our start pointer at the beginning was 1. We simply load that into the current pointer. Easy enough. Moving to the next line of code, we enter our loop and we are outputting my list current pointer and points to next pointer current pointer. So already, just by a simple traversal, we have some code that can get very confusing. And maybe you've been talking to your duck, and your duck's just not responding, giving you the answer you want. If you have no idea what I'm talking about, stick with programming. You'll eventually start talking to your duck. But we have our start pointer, which is 1, our current pointer, which is 1. But what is my list current pointer? That's the same thing as my list 1, and that is Casey. Next pointer, current pointer, 1, that is Casey. His pointer is 5. So that tells us we're going to output Casey, and it points to the next pointer, current pointer, which is next pointer 1, which is pointing to 5. So we move down to the next item, which is current pointer equals next pointer, current pointer. So all we're going to do is update that current pointer with the next pointer, current pointer. That's because Casey's pointer was 5. That is now the current pointer, so we can pull the next item. When we pull the next item, we have my list current pointer. Well, remember, we just updated it to 5, so that's going to pull Colby's name and also pull his pointer, which is 2. So Colby is my list current pointer, my list 5, and his pointer is 2. So that is where that comes from. Now, we go ahead and we update the next current pointer. So we load 2 into the current pointer. So now we are moving to index 2, which holds Jim's name. So we know we should be looking for Jim's name. That is our current pointer. We're looking at index 2. The data is Jim, and he's pointing to 4. Well, that's what this code says right here. My list current pointer, which is my list 2, because our current pointer is 2, is pointing to Jim. Then we are taking a look at his pointer, which points to 4. So my list 2 is Jim. The next pointer 2 is 4, showing the next item that he points to. Now, this could go on and on and on for quite a while because there are 8 names. We're going to skip ahead. But the first thing we would do is update the current pointer. So we update by the next pointer to the current pointer, which is 4, which points to the next item. That's what we're doing. Now, we're going to go ahead and skip all the way down, because if you follow the code, you would eventually get to the last name, Vinny, which is index 6. So we're looking at this, and it says loop until current pointer equals 0. We're going to be setting the current pointer to 0, because when I look at Vinny's pointer 0, the current pointer equals the next pointer, current pointer. Well, we're looking at 6, 0 gets loaded into the current pointer, and then we exit. Now, the reason we are exiting the traversal here with the 0 is because we emitted index 0 when we built our array. If we did not emit index 0 and we had used it, we'd be giving Vinny a pointer value of -1. So the next section is adding a node. So given the following data of names, put them in the sorted linked list. We have done that with the ability to add a node. So we've traversed a node. Now we need to add a node. And remember, we're going to give our array 10 indexes so we can add an additional name, which is what we're going to be doing here. Let's switch back over to Visual Studio. Let's take a look at code to actually add a node. Our add node procedure has a lot of code in it. So we have current pointer, local variable, that's an integer. We have add item because we want to know what item we're adding to our linked list. And then we need the previous pointer. We need to know what the previous pointer was, and we'll be getting into all that. So we simply add them. What name do you want to add? We store that in the add item. We set our current pointer and previous pointer to the start pointer. We have my list free space because we need the free space. That is where we're going to add the item. Is going to be at the end of our array. The benefit of a linked list is we don't need to sort it. We just tack it on to the end, and then we update our pointers. And then the next pointer free space, of course, is 0. We have if free space equals 1, then we increment it by 1. Let's pause here. Let me scroll back up. Let's pause here. Allow you to get this code before we move on to the next part of our code. And scrolling down, we're simply going to have a loop here. This is a post-conditional loop. So we have this. We're checking to see if the item we're adding is less than the current item we're looking at wherever we are in the linked list. Remember, it is sorted. Because it's sorted, I need to put it in alphabetical order. Now, you may be saying, well, how can a string know if it's less than another string? Well, it's based on the ASCII code. So a capital A has a lower value than a capital B. So when the computer is comparing items, it's not actually comparing the letters. It's comparing the ASCII code values. A, for example, capital A has an ASCII code value of 65. B has an ASCII code value of 66. 65 is less than 66, and that's how computers determine which letter comes first. So that's what we have. A lot of pointer stuff going on here. This can be very confusing, but don't worry. We're going to step through and actually take a look at what this is doing. What I want to point out is notice this else if statement. This is nested inside this if statement. It's very important that you know these are not two separate if statements. This one is nested inside this first if statement. Let's scroll down, take a look at our last line of code, which is simply an if statement and incrementing the free space, because if we're adding a node, we need to increment the free space. That seems pretty self-explanatory. Let's scroll up a little bit, allow you to get this loop down. Scrolling down a little bit to get the last bit of code here, this conditional statement or selection statement, the if statement, and then the incrementing of free space. Now, let's actually run this code and let's see if we can add a name and that it goes in the right spot. So let's go ahead and run our program. We see our program is running. We want to add a node. So we'll add herb computer science. You can add your name. It doesn't really matter as long as it winds up in the right space. Now, herb computer science should come after Colby. Now, I am being added to index 9. If I view the array, you can see that index 9 I've been added to. And the benefit of a linked list is we tack it on to the end, and then the linked list, we update the pointers. So now what we're going to do is we're going to traverse the linked list. If we traverse the linked list, it should read Casey, Colby, then herb computer science, and then Jim. So let's go ahead and traverse the linked list. We have Casey. Casey points to index 5, which was Colby. Colby points to 9. So item 2, which is Colby, is pointing to my name, herb computer science. But I needed to take Colby's pointer, who is pointing to Jim, and I need to point to Jim. And you can see my pointer is indeed pointing to Jim, and all the names show up as normal. They're all in alphabetical order. Our add node is working. But it's not just getting it working, it's understanding why it works. So let's flip over to the PowerPoint and let's run through each line of code. So the first thing we need to do is update add item. Now we were adding herb computer science. You may have added your name. That's fine. We need to update the current pointer with the value of the start pointer. We need to update the previous pointer value with the item of the start pointer. So we just take the start pointer value 1, we put it inside current pointer, we put it in previous pointer. Those now have a value of 1. Pretty easy there. Let's move on to the next spot. So the next spot says my list free space equals add item. next pointer free space equals 0. So what do we have going on here? Well, add item, we are storing in mylist free space. Well, mylist free space is 9 because our free space value was 9. So we're adding to the array herb computer science. But now what we have to do is update, you have to give the item we just added a pointer. And right now we're going to start giving it a pointer of 0. We will need to update that pointer, but we're going to start giving it a pointer of 0. That's the end of the list, but we haven't evaluated to see if it goes in the right spot. If it goes at the end, it's possible none of our other code runs because it's not less than, which means it would need to be the end of the list. So let's go ahead and jump into the next part of code, which is this right here. So our table is updated. We added the items. Herb Computer Science has a pointer of 0. We have not updated Vinny's pointer yet. We will, or we haven't updated my pointer yet. My pointer will point to Jim. We haven't updated my pointer yet, but we will do so momentarily. That's what the next code does. Don't forget, we have to increment the free space. Our free space was 9. Our free space then becomes 10. So we increment it. Now that we have our new table, we've added the item, we need to see, is herb computer science less than my list current pointer? Well, this is asking, is herb computer science less than my list 1? Well, what does that mean? Is herb computer science less than Casey? My list 1 is Casey. Well, herb computer science is not less than Casey. It is false. Because it is false, we jump to this else statement in our code. Our current pointer is 1, and we need to assign that to the previous pointer. So we do that, we give it a 1. Then we have to assign to the current pointer our next pointer based on the current pointer. Well, that means next pointer 1. What is the next pointer in index 1? That is the value of 5, and we need to assign that to the current pointer. So our current pointer is no longer 1. It's been updated, and it is now 5. That way we can check the next item in our linked list. So let's check our next item. Next item in the linked list is Colby. So we ask ourselves, is add item less than my list current pointer? Well, what is that asking? Is herb computer science less than my list 5? Well, Colby is in my list 5. Is herb computer science less than Colby? That is false. Herb computer science would not come before Colby. So then we run our else statement. We have our current pointer, which is 5. We're going to assign that to the previous pointer, which is 5. And then our next pointer, 5, is going to be 2, and we update that to the current pointer so we can check the next item. So next pointer 5 is 2. We put that in the current pointer so we can go ahead and check Jim. So let's go ahead and check that. So is add item less than my list current pointer? Well, this is asking, is herb computer science less than my list 2? Is herb computer science less than Jim? Yes, it is. That is true. So now we can execute some code rather than checking the next item because we found the right spot that it should go. So here's what we have. The next pointer free space is equal to the current pointer. Well, my free space, don't forget, was 9. We have not incremented it just yet. My current pointer is 2. So when I do next pointer free space, I'm assigning the current pointer to my pointer, next pointer 9. That becomes the value of 2. This allows me to point to Jim. So this allows me to point to Jim, not allowing Colby to point to Jim. So then we run this if statement. If current pointer equals start pointer, well, our current pointer is 2, our start pointer is 1. Does 2 equal 1? That is false. So this part does not run. However, the else statement does. And we simply update our next pointer, previous pointer, based on the free space. So we take our free space, we take our next pointer, previous pointer, which is 5, which means next pointer 5, this is Colby's pointer. It's going to update and now point to 9, which is pointing to item 9, herb computer science. We finish our if statement, we exit the loop. So that is what is happening here. We are simply taking 9. So this is our table updated with all the pointers. So we start with Casey. Casey points to 5. Casey points to Colby. Colby points to 9, which is pointing to herb computer science. Computer Science points to Jim, and then we follow the rest and it comes out in order. So our table is actually updated. Now we move to the next line of code. If current pointer equals 0, then we take the next pointer, previous pointer equals free space. So we check, does 2 equal 0? It doesn't, so we exit that if statement. And then finishing out the sub, we do free space equals free space plus 1. Because 9 is being used, we need to look at the next free space, which is 10. So what we need to do now is we've traversed the linked list. We just added a node. What we need to do now is be able to remove a node. Let's switch back over to Visual Studio and get the code for that. Just a reminder, when you're looking at your code, make sure you're removing these parentheses, because now that we have these procedures, these subs, we can actually do it. So I'm going to scroll down to my removing the node here. So what we have is we have current pointer as integer, previous pointer as integer, remove item as string. So almost very similar to what we had going on in the add node, but this time we're removing an item. So we ask them, or tell them, enter the item to remove. We're going to store that in the remove item variable, set up our current pointer and previous pointer with our start pointer, which has a value of 1, and then we have this if statement. This if statement is mandatory because we have to see if the first item we're removing is Casey. If we don't do that, our code will not work. Then we simply have a do until current pointer equals 0. Then if my list current pointer equals remove item, then we need to update those pointers. And once we update the pointers, because we found the item we're removing, we're going to exit that loop. We don't need to check it. If it doesn't equal the item we're looking to remove, then we're going to look at our next item. So let's scroll back up to the top so you can get this code. So here's the first part. Let's scroll down and you can pause the video to get the last part, the loop and the end sub. Let's see the code in action. We start our program, and this time what we're going to do is we're going to remove a node. So we're going to traverse the linked list, and we'll pick Colby. We'll pick Colby. So we have Casey, Colby, Jim, Juan, Riley, Steven, Taj, and Vinny. So we're going to go ahead and remove Colby. So we're going to remove the node. We're going to remove Colby. Now, I want to point something out. When we take a look at the array, Colby is still going to be there. Notice that Colby did not get deleted from the array, and that's because arrays are static, where linked lists are dynamic. What we're going to do is, Colby's still there. Colby is still there, but what we have done is we have updated the pointers so Casey skips over Colby and then points directly to me. So, or points to whoever is next. So that would be, let's see here, Colby pointed to Jim. So now it should go Casey, Jim. If I am correct, let's traverse the linked list and make sure those pointers are updated. So Casey points to 2. Notice he's no longer pointing to Colby because we removed Colby from the linked list. And Casey is indeed pointing to Jim, and we're checking the names. They are still in alphabetical order. It is still a sorted list. Now, we have our code, but let's talk about what the code is actually doing. Now we're going to walk through the code line by line to understand what it's doing. If you've watched any of my videos, you know I'm about understanding the code, not just writing or copying code. I want you to understand what the code is actually doing so you can become a better programmer. Now the remove item, we typed in Colby, that's who we're removing, and then we simply update our current pointer and previous pointer to the value of the start pointer. So we take our start pointer value 1, we load it in the current pointer, we do the same thing with the previous pointer. Very similar to what we did in our add a node code. Okay, so then we run into our first if statement and we remove a node checking item 1. So we look to see if my list current pointer equals remove item. So my list current is 1 and is Casey equal to Colby? That is false, so we move on and we check the next item in the list. So we enter our loop here and we just say if my list current pointer equals remove item, and that is repeating again for Casey. Now we could, if we wanted to, we could update this, but what if we had somebody else with a letter that starts with an A or B? We want to be able to check everything. So we're just going to run through the code. We're going to have this loop we're just going to update the pointers in our algorithm to check every item in the list. So we already know that it's false because it's literally running what we just ran. But when we update those pointers, now we can start checking the next one. Our previous pointer is loaded from the current pointer. That's what this line of code says. And then it says we want to update our current pointer to the next pointer. So we take our next pointer, put that in the current pointer, which is 5, and then we check the next item in the list, which we know is Colby. Our current pointer is 5, so we're checking to see if Colby equals Colby. It does. And once we have found the item we are looking for, we're done. We're done because we're going to hit this exit do line of code right here, which is going to cause us to exit our loop, and we hit the end sub, and that will be the final part of our program. Now notice I've blocked out what Casey is pointing to. Our current pointer is 5, our next pointer 5 is 2, and that's what this line of code is doing here. And because we are taking our previous pointer and we have removed Colby, we need to make sure that it points to the next item in the list. And what we do is we take this here, Colby's pointer, and then we assign it to Casey. So now when the code runs, when it outputs Casey, Casey knows he's no longer going to point to Colby. We have taken Colby's pointer and we have assigned it to Casey. That way Casey will point to the next item, which will be Jim. I hope you found this video helpful. If you found it helpful, please consider subscribing and give a thumbs up to help the channel grow. And we'll see you guys in the next one.